Students, today I will explain question number 5 of exercise 6.3. Now in question number 5 there are almost 7 sums or 6 sums are there. Okay, 6 sums are there. So all the numbers which are given, they are not a perfect square. Okay, because it is written they are not a perfect square, but you have to say with what is the smallest number that when you have to multiply with this, that is what is the smallest number that when you will multiply it with 252 you will make this number as a perfect square number. Okay, so this is what you have to say in each and every sum under question number 5. Okay, so if you just follow the first sum properly, I believe you will be in the position to do all the sums of question number 5. They are very easy. Okay, so when you see that in the question paper it is written what is the smallest number that has to be multiplied with any number they can give. Okay, that is 252 or 1008 or any number. Okay, so what is the smallest number that has to be multiplied with 252 to make it a perfect square, and also write the perfect square number. Okay, that means two questions you have to answer. One, first of all you have to say which is the smallest number, and what would be the number after multiplying that number with this number. That is, you have to also show that perfect square number also. Okay, so let's begin. For this type of question you will start with prime factorization, because it is how you will come to know that which number is unpaired. So let's start. That is divisible by 2. I guess now you have understood how to decide, seeing the last digit number. So 2 ones are 2, 2 twos are 4, 2 sixes are 12. Now 260, 3, it is divisible by 3, 21, 3 sevens are, and 7 ones. So if you write it in this way, 2 into 2 into 3 into 3 into 7. Okay, always remember that if any number is a perfect square number, then it will always have its factors in pairs. But because this number is not a perfect square, so you see that one of the number is not in the pair, that is 7 is not in pair. Okay, so how will write? See, this 2 is also in pair, 3 is also in pair, but 7 is not in pair. So how to write it down? This is very important. Hence, after doing this, hence prime factor 7 does not have pair. If 7 gets pair, suppose if 7 gets another 7 gets a pair, then the number means 252. Okay, the number 252 number will become a perfect square. Okay, therefore 252 has to multiplied with 7 to obtain perfect square. So this is the first answer, because what they said, what is the smallest number, so we have answered that is 7. Now we'll show what exactly it will happen when we multiply the 252. That is 252. Suppose again we'll write this but in a different format. Now we will multiply 252 with 7. Now if I'm multiplying this side, that is on the right and left hand side, I'm multiplying with 7. The same treatment I will do to the right hand side also. So we'll include another 7. Now you see, if I am multiplying 252 with 7, I have to also multiply the right hand side with 7. So if I am doing this, see, every number will be in the pair form. Okay, so this number will become a perfect square. But what is that number? So we have to write it down, we have to see it. So 252 into 7 is what? If you multiply, then you will get the answer as 1764. So this number is a perfect square. So this is the second answer. It was the second question, isn't it? What will be that particular number? So we have answered that. So when you're multiplying this with 7, so this is a perfect square number. Is a perfect square number. So this is how exactly you have to do all this. The first thing, what is the first thing we did? Prime factorization. Once you do the prime factorization, you will come to know which number is unpaired, and you have to give all this information. And finally, you have to multiply it on the left hand side, and the same treatment you have to do on the right hand side also. And finally, you have to multiply and show the perfect square number. This is the process that you have to follow. Okay, let's do sum number 3. This is sum number 3. So let's start with the prime factorization. 2 5s are 10, 0, 4. 2 2s are 4, 2 5s are 10, 2 2s are 4, isn't it? 2 1s are 2, 2 2s are 4, 2 6s are 12, 2 6s are 12, see again, 3 21, 3 7, okay. Now if you write it down, 1008, that is 2 into 2, 2 into 2, 3 into 3 and 7. So just make a pair. Again 7 is unpaired. So what you will write? Hence prime factor 7 does not have pair, isn't it? So if 7 gets a pair, then the number will become, number means what? Which number I am talking? 1008. The number will become a perfect square number. Okay, so now therefore 1008 has to multiplied has to be multiplied with 7 to obtain a perfect square. So we have answered the first question, which is the smallest number, 7. Now 1008 into 7 and on that side also we will do the same treatment. 2 into 2, 3 into 3 and 7 into 7. Now all the numbers are in pair. So now we have to really see what is that particular number, that is what is that perfect square number. It will be 7056 is a perfect square number. Okay, I guess your conception is quite clear now. So now I will be only doing the prime factorization. I won't be writing these things because you have already understood what exactly you have to write. I will just show that which is the smallest number that you have to multiply with the other numbers. Okay, so let's move on to sum number 5. So this is sum number 5, students. So 1458, what you have to do? 2 7s are 14, 2 0 4, 2 9s are 18. So it is not divisible by exactly 2. That's 3. 3 2s are 6, 3. Now 3 81s are, 3 27s are, 3 9s are, 3 3s are, 3 1s are. So let us write it down and see which number would be unpaired. I guess 2. 3 into 3, 3 into 3 and 3 into 3. So see, these all numbers are in pair, but 2 is unpaired. So this time we will write that hence prime factor 2 does not have pair. So if 2 gets a pair, then the number, that is this number, will become a perfect square. So 1458 has to be multiplied with 2 to obtain a perfect square. Then you will do this one, that is 158 into 2. Then you will again multiply this with 2. The same treatment. Okay. Now this is how you are showing that this number will become a perfect square, but you have to also show that what is that particular number. In this case 2 8 is 16, 1 2 4 is 10 11, 1 2 4 is 8 and 9. So this is the required perfect square number. Okay, I guess I'm quite confident now all of you can do the rest of the sums of question number 5. So today's assignment is question number 5, all sums. Okay, all sum 1 to 6. Fine. For reference, let's see, I can send you the solution also. Thank you and take care.